first, let's take a look at this next example. The company Drug Test Success provides a test for marijuana usage. Among 300 tested subjects, results from 27 subjects were wrong. Use a 0.05 significance level to test the claim that less than 10% of the results were wrong. So where we're always going to start with on these hypothesis testing problems is we're going to start with our claim. And our claim has to deal with that they were claiming that less than 10% of the results were wrong. So what we're going to start out with is our claim. So let's start by translating our claim. Well, first of all, we need to talk about what symbol we're going to use, whether or not we're going to use P, mu, or sigma. And then we'll also talk about what inequality we'll fill in: less than or equal to, greater than or equal to, less than, greater than, or not equal to. And then we'll fill in our value that comes after that. Well, right off the bat, because we are talking about a probability or a percentage, we're going to use the P. So we're going to start out with our claim having a P in it. And then they said less than, not less than or equal to, so it's going to be just a strictly less than. Less than what? 10%. Remember, we have to turn that into a decimal. So our 10% is going to get turned into 0.10 or 0.1. Now the question is, just like when we were doing these before, to make sure that this is set up correctly, we have to decide where this is going to land. Is it going to land as our H0 or as our H1? Well, let's see. We've got a less than with no equal to on it. Remember, if it doesn't have an equal to on it, it's going to be definitely our H1. So we'll go ahead and input that. The P is less than 0.10. And I'm going to go ahead and also label that as my claim, so that'll help me later. Then I can also fill in the H0, the null hypothesis, because it's going to be the complement or opposite, which will also have a P with the 0.10 is just going to be pointing the other way. So instead of less than, it'll be a greater than. But again, remember with the null hypothesis, it has to have the equal to as well. So that is going to be our huge setup, is that we've got our H0, our H1, we've got the correct symbols, we have our claim labeled, and we are all set and ready to go, because at least this is going to tell us what we're going to do. Okay, so what next? Well, because we've got proportions and we're doing a hypothesis test, we know we're going to do a 1 prop Z test on our calculator. The question is, what are we going to actually enter into our test on our calculator? And if you've forgotten how to get to your test on your calculator, remember we're going to hit the stat key, and we're going to arrow over to the right twice to tests, and then you're going to have to scroll down quite a bit until you get to the 1 prop Z test. So the first thing that the calculator will ask for is the P0 or the P0. It will also ask for an X, an N, and it will also ask for, with respect to the prop, it's going to ask for one of the following symbols, either a not equal to, a less than, or a greater than. A less than or a greater than that we'll have to choose between. And then at the very end, it tells us to calculate. So let's go ahead and fill this in. So the first thing that we're going to do is our P0. Remember that the little naught, the little zero, is a reminder that you want the P value or probability value from your H0. Well, if you go back to your H0, your probability, your P value was 0.10. So we're going to go ahead and fill that in. That's your 0.10. Next, they want our X and our N, which is coming from our P hat. Remember, p hat is x over n, which should be from our sample. Well, our sample said that 27 out of the 300 were wrong. So that means our x is the 27 and our n was the 300. So our x is 27 and our n is 300. Then the last part they're asking for is what symbol needs to go in that last slot, because that's going to tell them what kind of tailed test to do. Well, that is always going to be determined by H1. So if we go back to H1, notice that there's a less than symbol. That means we're going to select the less than symbol here as well, because it's going to be based on H1. Then you'll go all the way down to the bottom and click calculate. So let's see what it should look like in our calculator if we take a look at the next little picture. So if we look at the next little picture, what you should be looking at is something that looks exactly like this once you've got everything typed in. Then once you press calculate, what will come out from the calculator is the following screen. Now, we're going to learn two different ways to do these problems. We are currently doing the p-values approach, so I'm only going to be using the p-values. Later in a couple of minutes, we're going to learn how to do this using rejection regions. When we learn how to do these using rejection regions, then we'll use the actual z-value. Right now, we're just using the p-value. Now, because our H1, if you remember right, had a less than, we know that the picture that we're going to be drawing is a left-tailed picture. And what's going to go in that left tail is always going to be our p-value, or tails. If we actually have two tails, our p-value will go in between both tails, but we only have just one if it's left-tailed because it's less than. So our p-value from our test, which was the 0.28, is the area in that tail. You could double check it. It actually came from the z-value we've got from the one prop z test as well. So if you really wanted to do that, you could test this using that z-value that we came up with, using a normal CDF and getting all the area to the left, and you'd get the 0.28. Either way. So the question now is, we've got a picture, we've got a p-value. When you're doing the p-values approach, that is all you need to actually come up with your answer. So what we now have to do is ask ourselves a question, and the question will always stay the same. So let's see what our question is. Our question is always going to be the same. It's going to be, is p less than or equal to alpha? Well, p, we just found our p-value was 0.028. The only thing we really haven't talked about much here is alpha. And alpha is our level of significance if we go back to the original problem that's given to us. So if we go all the way back up to the original problem, the level of significance is 0.05. So we can use our level of significance of 0.05 here for our alpha. And this should be a simple yes or no question that you're asking. So, is p less than or equal to alpha? No. The question is, what does no mean? Yes means that you reject H naught. No means that you fail to reject H naught. So the question is, what does fail to reject mean? Well, here, let's rewrite our H naught. Let's get into this habit of rewriting our H naught and our H1, and then we'll write out a sentence about this. So our H naught was that p was greater than or equal to 0.10, and our H1 was p is less than 0.10, and our claim was actually our H1. So we are failing to reject H naught, which, remember, that means we're going to do the reverse with our H1. Instead of failing to reject, we're actually going to fail to do the opposite, fail to accept H1. The question is now, what does this mean? Now, which one of these do we care about? Because we're only going to always care about one. Well, we're always going to care about whichever one has our claim. And according to this, our claim is our H1. And what are we doing with it? We're failing to accept. So the question is, how do I translate this into a sentence? Well, failing to do anything means you weren't able to do anything one way or the other. It means your test was inconclusive. So what we're going to say is, because we're failing to do something, is that there is insufficient, meaning not enough evidence. So this is basically you saying that the test was inconclusive. Inconclusive to do what? There's insufficient evidence to, we are on our H1, accept our claim. And that's it. And what this is a fancy way of saying is, I don't have enough evidence to accept my claim. My test was inconclusive. That's it.